So I've made quite a lot of 3D and GameMaker tutorial videos over the year, and there are some subjects that I've wanted to cover for ages, but they just keep getting pushed farther and farther back on the to-do list because really just other stuff comes along and I get distracted. So today it's finally time to talk about Mipmapping. Hello all the crazy people out there, my name is Michael, I like wizards and dragons and making games, and I want you to take a look at what you see on screen in front of you and tell me if you can see anything that looks maybe a little bit off about this image. Perhaps I'll give you a hint. The parts of this infinitely repeating texture that are far away from the camera, if you think they look a little bit grainy to you, well, it's not just you. So this is a common problem that can happen when you try to sample from a large texture at a distance. Depending on what your source image looks like, it can come out looking a little bit grainy like this. You can end up in other situations, you can end up with a pattern that's a bit of a moire pattern. I know I am not pronouncing that correctly. That word is French. That's my official excuse. And Mipmapping is a strategy in computer graphics which aims to deal with that. It can also be used for a few other things. Among other things, it can be used to somewhat improve the speed of rendering large textures at a distance for reasons which I'll discuss later. And it's a good thing to know about. It's something that you can do in GameMaker fairly easily. We're going to talk about how it works. First, before we talk about how it works, I suppose I should talk about what it is. So Mipmapping is basically the practice of creating and using multiple levels of details for texture images in much the same way that you would create and use multiple levels of details for visual 3D object meshes. So when you create a Mipmap, what you're going to do is take your base texture and you're going to downsample it by a factor of 1/2, and you can do this multiple times. So if this ground texture that I'm using right now is 1024 by 1024, we can create a series of downsampled images in descending order. One that's going to be 512 by 512, one that's going to be 256 by 256, one that's going to be 128, 128, and so on down the line. You can slide between these levels of detail based on how far away from the camera the thing you're trying to draw is. You'll see in a minute what that looks like. Anyway, in GameMaker, setting this up is pretty easy. I'm going to go to the Tools and the Texture Group Manager. And this is the wonderful little tool that has a bunch of various settings for all the different texture groups in your game. So this is something you're going to want to do even if the texture in question is going to live on a separate texture page, which if you're using this for 3D, it probably is. Even if textures in GameMaker are marked for separate texture pages, you can assign them to texture groups anyway, and they will inherit the properties of that group. It wasn't always like this. I can't remember exactly when this change was made, but it was a while ago now. Anyway, I can work in the default texture group, or I can work in I can create another texture group and call it like text_mip or something like that, and we can put any and all textures that we would like to use Mipmap settings on this texture page. Again, this will still be marked as a separate texture page, but it will belong in the Mipmapping group, and that is the group that we will use the settings of. You can go check this box. It says Generate Mipmaps over here. This will increase the default border size when you do this. That's generally fine. Again, textures that you're using this with generally will be marked for separate texture pages, so that kind of won't matter anyway. But just in case you're not, maybe be aware of that. Let's see. So that is one thing that we need to set up. Another thing that we're going to need to set up is in our draw event. So when we go to draw our 3D world, the same way that we might or might not want to set up various properties such as Z write and Z test or text repeat, backface culling, that kind of thing. So if you type mip_ hit control space to bring up code help, you'll see that there are quite a few functions in GameMaker which relate to Mipmapping. The list isn't actually quite as long as it might look at first glance, so a lot of the Mipmapping functions have basically aliases that will affect either all textures globally or will only affect a single texture sampler. So in the same way that like GPU set text repeat or GPU set text filter can be turned on or off either for all textures globally or for a specific sampler, so can all the Mipmapping functions. We also have getters and setters for pretty much all of these, so while it looks like there's quite a lot of Mipmapping related functions, a lot of them are related and can be discussed collectively. So the first thing I'm going to need to do is turn it on, turn Mipmapping on. I'm going to say GPU set text mip enable. This is going to take not a true false as it might look at first glance, but one of three options. So there's mip off, which is the default setting. This will be no Mipmapping at all. Turn it off. There's Mip on, which is going to be turning it on for all textures, and there's Mip marked only, which is probably what you want most of the time if you're going to be doing this.
Hey.
This will only turn on Mipmapping for textures which are marked for doing so in their texture group, like I just did with this texture group here. Next, let's talk about Mipmap texture filtering. So I can say GPU set text Mip filter. And this is also going to take one of a few values. One can be TF point. So this is going to be point filtering. This is the simplest kind of texture filtering when it comes to Mipmapping. We also have TF linear and TF anisotropic. And I'll show you what each of these look like in turn later. Probably TF underscore anisotropic is the one that you want most of the time. But again, I'll show the comparisons later and you can make the judgment call yourself. Let's see, what else do we want? So not all of these are necessary, but a couple other settings related to Mipmapping that you might be interested in are GPU set text Mip bias, text Mip bias, GPU set text Mip bias, and this is going to be basically a minimum level of detail that you can use if you want your game to have texture quality settings, and if you want to give the user the option to like default to a lower texture quality. Maybe if they're trying to run your game on like a GTX 750 or something like that, that's a little bit on the old side, and you want to let them take some of the load off. You could use GPU set text Mip bias to accommodate for that. So by default, it's going to be 0. Higher bias values are going to be basically fudging the Mipmap level in the lower, for lack of better words, the lower quality direction. And again, I will show off some of that later on. And lastly, we have GPU set text Mip, set max and ISO. That's just it. GPU set text max and ISO. And this will affect the anisotropic filtering level of your Mipmaps if you're using that. This will range from, I want to say 0 to 16. What is the maximum? All right, the default is 16. The minimum is 0. I don't know if you can really set it higher than 16 to any like relevant effect. I guess I'll leave that as 16 for now. Let's see. Some other functions that I'll name by name, but won't play around with. You can set the minimum and maximum Mipmapping levels. Again, this relates to like texture quality settings that you might or might not care about. I consider that less important than the Mip bias setting, so I'm not going to spend a lot of time going over that. So if I run this, we'll immediately see some differences. You can probably already see it. If I go and screw off all the way into the corner of the room like I was at the beginning of the video, it'll be a lot more pronounced. The camera speed for this demo is not the fastest. Alrighty, here we are in the corner of the room. You can see that the parts of this texture that are off in the distance are already a lot less grainy. They're a lot smoother looking. We have taken care of the graininess issue or of the moire pattern issue that you might see exhibited in 3D games if you don't use Mipmaps. Another thing that you might notice is that the frame rate that's being shown in the corner here has actually gone up quite a bit since the beginning of the video. I want to say in the beginning of the video it was hovering around like 1500, 1600 with the camera sitting about here, and here it's almost doubled, up from 1500 to almost like 2800, maybe even a little higher than that sometimes. And that is due to the second big advantage of Mipmaps, which is that they can speed up rendering because they are a lot more cache friendly. So what do I mean by that? So right now it's current year and everybody's getting excited about AMD's Ryzen 7800 X3D chips and whatnot. And the big deal about those is that they have a lot of memory on the CPU, what is known as the level 1, 2, and especially 3 cache, which is something that games tend to care quite a lot about, because it means the data that has to be accessed frequently can be accessed a lot faster, because it takes a lot less time to access data that lives in memory that's physically on the CPU versus data that lives physically way the heck off on the other side of the motherboard. So CPUs aren't the only chips in your computer that have on-site cache. Graphics cards, of course, have onboard video memory, which exists for basically the same reason. But on top of that, graphics cards also have varying levels of memory cache that lives on the GPU die itself, which is used for more or less the same thing. My GTX 1060 has 3 gigabytes of video memory, which is fine, honestly. I don't have a problem with playing my games at lower settings, but relevant to this discussion, it only has about 2 megabytes of L2 cache, which is used for the data that's actually being drawn right at this very instant. That's not exactly enough to store this entire 1024 by 1024 texture in L2 cache at once. So my GPU and my DirectX/OpenGL/Vulkan drivers will do their best to try to load the part of the texture into the GPU's cache that will be most relevant to what is actually being drawn. And for reasons which I think it is acceptable to gloss over in a GameMaker video. Usually that means that when you are sampling from a texture when you're drawing something, that means that pixels/texels that are close together are going to be used for rendering at the same time. And that works well enough, but if you're drawing a large texture that's far away from the camera, you can end up with situations where, let's say one pixel is going to sample from a texture that's over here in this part of the texture, and then its neighbor immediately adjacent to it is going to sample from the texture over here, and the pixel that is like on top of or below or whatever is going to sample from a part of the texture that's over here. And this really doesn't do any favors to the concept of memory locality or cache locality. And when you sample from parts of the texture in basically what amounts to random places, you increase the chances of a cache miss, which means that the data that you're trying to use is not in the GPU's cache, and it has to instead go over to like regular VRAM, or God forbid, into like actual RAM if you run out of VRAM. So if you have a large texture that's being drawn far away from the camera, where it doesn't actually resolve to that many pixels on the screen, if you can sample from a much smaller texture, you can fit more of the texture in the GPU cache at once. That increases cache locality, that decreases your chances of a cache miss, and you can potentially render the scene much faster. And this is a bit of an extreme case. This example here is a bit of an extreme case because, like, there is nothing in this scene except for a repeating texture, and a lot of it is very far away from the camera. And I'm definitely not saying that you'll automatically double the performance of your game if you just hit the use Mipmapping or generate Mipmaps checkbox in texture settings, but for certain specific bottlenecks in your game, it can definitely help. This is, by the way, the same principle is also why Mipmapping tends to look better. So when you sample from a pixel and its neighbors are like way off in random parts of the texture map, because the thing you're trying to draw is very far away from the camera and individual fragments are far apart in texture space, you're basically going to end up at a certain distance sampling from random textures on the texture map, and that's why it's going to look like either noise or moire patterns, again, depending on the contents of the texture that you're actually dealing with. Mipmaps get around this problem because when they downsample the image, they will also start to blur neighboring pixels together. So the stuff that you end up sampling from the texture map ends up being more of the average of all the pixels that are in the vicinity of what you're sampling, rather than random pixels from random parts of the texture map. Alright, so that's a fun little exercise, but you are probably wondering what this looks like in a bigger project. So I'm going to be, I might or might not have gotten a little bit carried away when I was planning out this video. And I have, in another sample project, well, you'll see in a minute. So this is the Hyrule Circuit course from Mario Kart 8, or at least most of it. I didn't bring in like normal maps and specular maps and that sort of thing. Anyway, this is Hyrule Circuit from Mario Kart 8. The models resources are wonderful, wonderful place on the internet. And I have over here a little debug view, which will let you control various settings related to Mipmaps. So right now it's defaulting to on. If I wanted that to default to off, it's actually going to freeze for a minute because GameMaker will generate or like discard Mipmaps on the fly when you change that setting. If I turn this off, you are going to immediately notice that this is a lot grainier, and also that performance is tanked from whatever it was before to about 700 FPS. And this is like actual FPS. This isn't FPS real because this is an uncapped frame rate that it's running with. I would run this on the Raspberry Pi, but it might melt it. Anyway, so like at close distances, this looks alright, right? This grass texture, it's fairly high resolution. These brick textures on these houses, the brick textures on the road, on the side of the castle, that kind of thing. But that looks fine at close distance, but when you start to zoom out, you will start to notice that the texture is looking very grainy, for reasons that I explained before. We are basically sampling from random points on the texture map, and that's going to give us a bit of a grainy effect. However, if I turn Mipmaps on, if I turn it either on or on marked only, it doesn't really matter, we'll get the same thing. It's going to take a couple of seconds to basically create the Mipmaps for us, and just like that, our FPS has jumped from 700-ish to almost to 1800, so it's actually more than doubled in this case, so that's pretty neat. You'll also notice that it looks much better, it looks much less grainy, because again, we are basically smearing out or averaging, I guess smearing out sounds like a bad thing, we're basically averaging together the density of pixels at a far distance, or texels at a far distance, I should say. I usually use those words interchangeably, but here it actually kind of does, like, matter which one you're talking about. I feel like this texture is not correct. I might have messed something up there. But anyway, let's see. Now we can start playing around with various settings. So probably the most obvious, if I stand here close to the ground, if I turn the MIP bias level up a little bit, we can see that the quality of the textures in the near field is going down, and the quality of the textures in the far field is going down. And the FPS has gone up by a little bit. It actually hasn't gone up by that much, because I imagine at this point, like, texture locality, memory locality is not the bottleneck in this situation, rather like the number of shading units I have and how fast we can actually process the triangle data. Anyway, you can actually set that to a negative value if you want a negative mipmap bias, if you want higher quality textures off in the distance, but that kind of, like, defeats the purpose of what we were doing before. So I don't know if that's really the desirable outcome. We can change the MIP filtering from point to linear, which I honestly really can't see that much of a difference.
Hey.
Maybe if I were to like overlay a before and after image, I'd be able to see the difference. And we also have anisotropic, which I sort of can see a visual difference, but if you ask me to, like, identify which is point and which is aniso, I don't think I'd be able to. Aniso specifically affects how texture filtering is handled when you're looking at, like, textures at a very low angle like this, at a very oblique angle. That has to do with how textures appear stretched at low angles like this, but honestly, like, my eyesight's not that good. I doubt I would really notice the difference between any one of these. I expect anisotropic filtering is the most expensive. You can also turn the aniso setting down if you wish. I think this is a logarithmic scale, so it doesn't really make sense to have, like, a setting of 12 or 13 rather than, like, 16 or 8 or 4. But anyway, let's see. So I can fly around this. I can have a look at how various, like, aspects of this race course look when you're using, like, point versus aniso filtering. I will have a link to the models resource page where you can download the Hyrule Circuit course and other Mario Kart 8 courses if you're so inclined. But I'm not going to just make this available on GitHub because copyright Nintendo. But I did think it would be really useful to have an example like this with a lot of stuff going on, so that you could see the difference in not only, like, visual quality, but also in performance. A couple last things to discuss before we part ways for the day. So, GameMaker seems to be perfectly happy to handle mipmapping for you. I was actually under the impression that, at least in OpenGL, you would have to write some additional shader code yourself to do this. I don't know if that's, like, a difference between DirectX and OpenGL. I don't know if that is, like, something specific to the version of OpenGL that GameMaker uses, but I'm just going to talk about it anyway. So you might have noticed that the texture 2D function in your shaders in GameMaker will take an optional third argument for the bias. This has to do with mipmapping. This is going to be a number between 0 and some positive number, where 0 is, like, the default texture, 1 is the first MIP level, 2 is the second MIP level, and so on down the line. This is going to be a floating point number, so you can have a 1.5 if you want. And the best way to automatically calculate the one that you should use that I've seen on the internet is going to be something like float, off by one error on my hands on my keyboard, float get MIP level. And this is going to be a function which is going to return a floating point number for the MIP level, as the name implies. It's going to take as an input a vector 2, which is going to be the texture coordinate, so I'm going to call that UV. So we're going to be using partial derivatives here. Like I mentioned at the beginning of the video, fragments that are being rendered that are far apart in pixel space are going to want to use a higher MIP level. So to figure that out, I can say vec2, let's say dx, or let's call it text dx equals df dx. You can just take the df dx of the UV coordinate. Vec2 text dy is going to be df dy of the UV coordinate. So we are going to want to compare these to each other to see like what the largest value, what the largest gradient in texture space is. And we can do that by taking, let's say, the dot product of text dx against itself. And we can compare that to the dot product of text dy against itself. That's basically going to square this vector 2. So this is going to return a vec2 containing the gradient of this of the UV coordinate. And we can just take the max of whichever one of those two values is bigger. I'm going to call this float max gradient is going to equal this. Let's put this all in one line. And we can say that the float mip level is going to equal 0.5 times the base 2 logarithm times the log 2 of max gradient. And because logarithms can return a negative number, we're going to want to take the max of 0.0 and half of the base 2 logarithm of that max gradient. And now we can return mip level. So using this, we would be able to say in our main function, for example, float mip level equals get mip level. Our input parameter is just our texture coordinate, and we can pass that in as the optional argument to the texture 2D function. We can use mip level for that, and we can be on our way. This is our sample project, isn't it? Again, GameMaker seems to handle this automatically. Like, this looks pretty much the same as it did before. I don't know if that's a DirectX versus OpenGL thing, but while this isn't really needed in my case here, if you are running your game on like mobile devices or something, you might need to consider this. This also just like fetches the mip level. It also doesn't take into account things like the LOD bias or the like the min or max Mipmap LOD level. I don't know if that's something that you would need to take care of yourself, but anyway, it seems to do the trick. Let's see. So lastly, some situations where you might not want to do this. If you are using low resolution textures on purpose, like pixel art, you probably don't really need to deal with this because obviously low resolution pixel art texture takes up a lot less memory, and memory bandwidth and memory locality is much less of a concern if all of your art is small to begin with. And also, like, unless you're really stretching it far into the distance, pixel art is somewhat less likely to cause noise / moire patterns. Again, there are fewer texels all around, and there are fewer texels to, like, sample from randomly and create noise, but I don't know. Maybe if you were making a pixel art game, but that was the size of, like, Octopath Traveler, this is still something that might be relevant to you. It is worth mentioning that since Mipmaps are additional texture images that have to be generated for systems like this, enabling Mipmaps will take about 50% more video memory, at least for the textures that have Mipmaps attached to them. And for this reason, things like UI elements or sprites that exist at a fixed size in 2D space, you probably really don't want Mipmaps on those because you're not going to use them, and there's no point spending extra video memory on it. I'm actually not sure, and I'll go and see if I can probe this now, but if you set your MIP bias to some high value, like this, will GameMaker actually, like, automatically unload the higher MIP levels that you aren't using? So apparently, Windows Task Manager has for some time now, and I never found out about it, Windows Task Manager has for some time now frozen on me. Right, here we go. Windows Task Manager has for some time now reported the amount of VRAM that individual processes use, and I, like, never knew about that. Right now, this Hyrule Circuit project is going to consume about 250 megabytes of video memory, which is actually less than I thought it would with Mipmapping on. If I increase the MIP bias, are the old ones going to be unloaded? Like, are the higher quality images going to be unloaded after a time? It doesn't look like they are. If I turn them off entirely, this VRAM consumption should drop. Okay, I see we didn't drop like 30% or whatever the equivalent to 1.5x increase would be, but we did drop a bit. And right, I'm gonna guess that a lot of the remaining VRAM is for like the frame buffer and the frozen vertex buffers and whatnot. But anyway, Mipmaps. They're cool things. They're not super hard to set up. I would encourage you to use them if there's something that you think your game needs. By the way, in case it wasn't obvious, this is at the very least the like anisotropic texture settings or the Mipmap bias level are settings that it might not be a bad idea to include in your game settings menu if you want to include quality settings alongside things like rendering resolution and other things like that. But yeah, you can have fun with that. My name is Michael. I like Wizards and Dragons and making games. If you want the code for this, look for the link to the GitHub repository down in the description of the video. I will not, again, have the Hyrule Circuit course on GitHub, but I will have all the other stuff up there in case you want to play around with it yourself. I like to post videos on the weird stuff you can do in GameMaker, so if you're interested in 3D stuff or shader stuff like this, feel free to subscribe. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. You should all go check out the Steam page for Wizarducks, which is the game that I like to work on when I'm not doing YouTube stuff. Link to that Steam page can be found down below as well. I hope you all found this useful, and I will see you all later. Special thanks to Zenjamin, VitroV, Squarecrow, MantaRay, GameMaker, Edward Holt, and DJ Gibbles for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.